Here's an application problem to find the maximum area of a rectangle, and we're going to use quadratic function. Here's what we're giving you. We give you a rectangle. It is to be constructed with the perimeter of 50 centimeters. Remember, perimeter, if I have a rectangle, that's x plus x plus x plus x, whatever that total is. If one of the sides measures x centimeters, find a formula calculating the area of the rectangle as a function of x. Please pause when you need to. So the first thing I'm going to do is draw a picture of this rectangle. Remember, the rectangle has a length and a width. Two different variables, x and y. When we want to write it as a function of x, we have to make sure both variables are exactly the same. So right now we have an x and a y. So let's write the equation for the perimeter. Perimeter is taking x plus x and y plus y. And the perimeter is 50. So 50 equals 2x plus 2y. Let's solve this equation for x. So I'm going to subtract 2y from both sides. So I'm going to solve for y. I'm going to subtract 2x from both sides. And then divide both sides by 2. So I get y to be 25 minus x. So this 25 minus x can replace right up there, 25 minus x. So now I've rewritten the y as x. So if I create this rectangle again, my length is x and my width is 25 minus x. So here's our first question. Find the function with area. So remember, the area of a rectangle equals length times width. Here's our length, here's our width. We multiply these two numbers together. So we get length of x and width of 25 minus x. I'm going to write it as a function, so a of x equals x times 25 minus x. I'm just going to put this not in factored form, but in standard form. So I'm going to just distribute this x through. So I get 25 x minus x squared, and then I'm going to put it in descending order. So I get negative x squared plus 25x. This is my first part of my answer, writing the function. Now think about this function as a quadratic equation. Let's graph it with a graphing calculator. So when you enter a graph into a graphing calculator, you're going to say y equals, and then negative x squared plus 25x. So if you have a graphing calculator, go ahead and enter it in now. I'm just going to save a little bit of time and enter it on my own calculator. Or you can use one of mine in class. So this is a quadratic function. So that means the shape of this graph should be a parabola. And our leading coefficient is a negative. So that means our parabola is going to open down. So our parabola is going to look something like this. We have an x-axis. What that x-axis represents is your x in centimeters. That's the width of your rectangle. And then your y-axis represents your area, and that is in centimeters squared. If I ask you for the domain of this parabola, my original function before I factored it out was x, and then I'll just go up to here so you can see it where I'm pulling this from. X and then 25 minus x. Here it is in factored form. If I set this function equal to 0 to find its domain, I'm using that zero product property. I set each factor equal to 0, and I solve for x. So x equals 0, so that's one of my x-intercepts here. And then set this one equal to 0. X equals 25. There's my other x-intercept. So I know that my domain has to somewhere between 0 and 25. I can't get any bigger than that along my width. All right, the next part is to find that maximum. So we could use a graphing calculator and approximate that maximum point. This is also what we call the vertex of our graph. So we gave you a little hint in our class that to find the vertex x value, it's opposite of b over 2a. And then to find the y value, you just plug that x into the function. So here's my function a of x equals negative x squared plus 25x. And I want to find the vertex. My a value is negative 1. My b value is 25. So to find the vertex, x equals opposite of b over 2a. Opposite of b is negative 25. A is negative 1. Negative 25 over negative 2 is a positive 12 and a half. So we go back up to our graph. This would be our line of symmetry at x equals 12 and a half. There is our maximum width of our box, our rectangle. We want to find out what is the maximum area. Then we have to find out what a of x is, this piece right here. So to find a of x, we just substitute 12.5 into the function. So we're using this blue function right here. And then 25 times 12.5 is 312.50. All right, so now we know our maximum area is 156 centimeters squared. And then this is our maximum width for x. If we wanted to know the dimensions of this rectangle, remember x was 12.5 we just found. And then this side here, y equals, we change it into an x form of 25 minus x. So I'm just going to substitute x into this. So 25 minus 12.5 is 12.5 centimeters. So our dimensions is 12.5 by 12.5, and then our maximum area is 156.25 centimeters squared.